1, 2, 3. Well, hey guys, back to virtual learning. So we're back to 1, 2, 3. Hey guys, we're back to virtual learning. So that means play posits. I was going to start something new, but doesn't work with the virtual learning as well. So today we're talking about tides, the last wave. So a tide is a rhythmic variation of a sea level, and it has a period of approximately either 6 or 12 hours, depending on where you are on Earth. The highest tides on Earth can be found in Canada at the Bay of Fundy, which is what this is a picture of. It separates New Brunswick from Nova Scotia. The highest tides in the United States are found near Anchorage, Alaska, with tidal ranges of about 40 feet. That's huge. So tides are caused by an imbalance between gravitational attraction of the sun and moon and the inertia of the water on the rotation of the Earth. So in order for there to be no movement, if we didn't have any tides, the forces would be equal. But they're not equal. So without that equality, we have movement. This is Newton's first law. If they're unequal, movement occurs. I'll watch a quick video. 1, 2, 3. There are a lot of misconceptions about what causes tides. So let's look at some of this. Does the moon orbit around the Earth? Well, no, it does not orbit around the Earth. The Earth and the moon are a system, and it rotates around a common center of mass that happens to be inside the Earth. And also, it orbits around the sun. Tides are caused by the moon's orbit. Well, think about the question above. No, they're not caused by the moon's orbit. Tides result from the rotation of the Earth on its axis every 24 hours. So there is a difference between that. So let's start with the gravitational pull of the moon on Earth. Yeah, I know, it's gravity again. Oh my goodness. Math, not really. So the bulge of water on the moon's side of the Earth is a high tide. So the moon has a certain amount of gravity, and it's pulling that water towards it. So that gravitational pull generates something called a tidal force. And the tidal force causes the Earth and its water to bulge out on the side closest to the moon. The red line is the center of gravity with that. So how do we explain the other bulge on the other side of the Earth away from the moon? Well, the other bulge is the result of both the Earth and the moon orbiting around the common center of mass. The center of mass of the Earth-Moon system is really deep in the Earth, about 1,650 kilometers down. Both the Earth and the moon rotate around the same axis. If they didn't, then the unbalanced forces of the moon would cause the Earth to leave its orbit. So just like you kind of feel a force pulling you outward on a merry-go-round, the water on the side away from the moon experiences that same type of force. It's not really a force, but it's a tendency of the object to continue in a straight line unless it's acted on by a force. And that's Newton's second law. This is called inertia. So one bulge is due to gravity, and the other bulge is due to inertia. The side where the moon is due to gravity, and the side on the opposite is due to centrifugal force. So now notice that the center of gravity is in the middle. So the 24-hour period of the tides, it's due to the spinning of the Earth on the axis. There's one revolution every 24 hours. It is not due to the orbit of the moon. However, it's also not exactly 12 hours. One, two, three. So there's some complications. The lunar tide period is not exactly 12 hours. Because the moon-Earth system completes one revolution every 27.3 days, the bulge goes completely around the Earth in 27.3 days, right? No. In the time that it's taken for the Earth to complete one revolution, the moon is moved 13.2 degrees further along. So the Earth has to actually rotate 373.2 degrees for a point to move directly beneath the moon again. So this takes the Earth 24 hours. The tidal period is actually 12 hours and 26.5 minutes. We actually will just round it out to 12 hours and 25 minutes. So there's more complications. The Earth's spin is tilted. So it spins on its axis tilted. So the moon moves from 28.5 degrees below the equator to 28.5 degrees above the equator every 27.3 days. At one point, the day and night tides are going to differ. So, one of the biggest complications is something that you see every day, the sun. Remember, the sun also has a gravity that is exerted onto the earth. So, it's a tidal force. Remember that gravity always sucks. Oh no, it's that gravity thing again. So the sun only exerts a force of about half of that of the moon. So why? Well, the sun is so much bigger than the moon. You would think that it would exert a much more gravitational force. However, the sun is so far away from us, it discounts the size of the sun compared to the moon. So another complication, there's a seasonal dependence. The Earth is about 3,700,000 kilometers further from the sun in the summer than in the winter. Winter tides in the northern hemisphere tend to be larger than the summer tides. Oh God, yeah, tell me she doesn't want me to do all this math. No, I really don't. But I do want you to be able to explain and answer questions like, what is the ratio between the tidal forces of the moon and the sun? And how can the sun exert a smaller tidal force than the moon when it is so much bigger?